This is very slow. Why? So in this multiple variable case, when you are going to bring change in the all the inputs, then how the output is changing, that relationship we will see. So there we are going to come across three laws. One, it is increasing returns to scale. Second one, it is constant returns to scale. And the third one, it is decreasing returns to scale. So here in this loss, we are going to compare the percentage change in inputs with the percentage change in output. How much percentage of inputs are increasing, and whether you are getting in the same manner there is a change in the output. If there is change in the output, what is the percentage of change in the output? So by taking into consideration these both the changes, percentages of input and the output, we will compare which comes under the increasing returns to scale and which comes under the decreasing returns and constant returns. So when there is increasing returns to scale, we can say that the percentage change in output will be more than the percentage change in input. So when output is more than the input, that stage is called as what? Increasing returns to scale. If both are same, the change in input and the change in output is the same, it is called as what? Constant returns. So constantly it is changing. Returns means here it is the output that you are going to get by change in the inputs. So if you increase, how much you are going to increase, equally if the output is going to increase, that is called as what? Constant returns to scale. And decreasing means you know that when input is more, input change is more, and the output change is less than the input, then we can say that it is decreasing returns to scale. So these returns to scale is also called as what? Returns to factors, because all those inputs are called as factors of production. No? So if we are going to bring change in the factors, how the output is changing, that we are comparing. So for that we can say that law of returns to factors also. The other name of law of returns to scale. So this is what I have explained, that I have shown in the words on the screen. So proportionate change in the amount of inputs and how the behavior of output, whether it is changing or not. So that is compared in this law. So as we said that we need 3 stages, no? So we will show all those things in one single schedule. So you need not go for 3 different schedules. So in the one single schedule itself, you create one example illustration, and you have to show the 3 laws in one single schedule. So how to show that in terms of values? So as we said in the same manner, in words we said no, the same thing we are going to convert it into the numerical values, and we will show in this schedule, which is called as law of returns to scale schedule. So for this we are not going to show all the inputs here, because it will be clumsy to show all the inputs. Simply 1 or 2 inputs I am showing, but you have to think that all those inputs are changing. Okay, so here capital I am changing and the labor I am changing. So what is the change in the capital and what is the change in the labor? That is shown in the percentage increase in both the inputs. So here we are not going to substitute capital or labor for each other as we have done in the isoquants. Okay, so like that you are not going to substitute. You are going to increase both the inputs equally. Okay, because all the inputs should be increasing, and we need to find out how the output is increasing, right? So for that, both capital and labor that I have taken here, I am going to increase, and the output some quantity at one inputs. So that we are going to show in the output column. And what is the percentage change in the output that you have to calculate. So after finding out all this input increase in the both the inputs and increase in the output, we will compare the these two. And when increase in inputs is more than the output, that is treated as what? Increasing returns to scale. If both are same, constant returns to scale. So like that we have to show here. So to get that, we will take the values in the same manner. And what is the law that is applicable there? So what, under which type of law it is going to lie. So that type of law we are going to write in another column. So for this, all these columns we have created. So now let us take capital and labor. Think that it is capital is 1 lakh and the labors that are used here is 3 number of labors. So here we are not going to compare the percentage because after change only we can say no what is the percentage at the beginning. At the beginning, this is the situation where 1 lakh capital is used and 3 laborers are used, and you are going to get the output of 60 units. So with this, we are going to bring change in the next stage. So it will be very easy to show that 100% increase in the inputs we have to take. Okay, so 100% means it will be very easy. If you double the previous one, you will get 100% of inputs. No, so double this simply. So take 2 capital and 3 means double the 3, it will become 6. So which indicates that 100%. So to calculate this also we are having one formula. So increase in inputs you can see on the screen, I2 minus I1 divided by I1 into 100. Okay. So the second one that you are going to take as I2 and the first one you take it as I1 and divide it with the first one. So and multiply it with 100, you will get the percentage. This formula also you can use. So here simply we have taken by doubling. No? So no need to use this formula. And simply you can find out 100%. Otherwise you take the calci. Once I will show you how to calculate in the next changes. I need not to do that again and again. Okay, so for that I am taking this calci. Let the calci come. Now see, let us see the difference between the labor. 6 is there, no? This is 6 is I2 minus I1 is 3. Okay, minus 3. So divided by 3 into 100. So how much it is getting? 100%. Okay, na? So like that you can calculate even if you take any other value, you can use here. 100% it is taken. For output also you are going to use the same formula. So for output I have given here O2 minus O1 minus divided by O1 into 100. Okay, so here I am bringing change in the output up to 150. So 150 units, suppose it is output is increased when you are going to use 2 lakhs of capital and 6 laborers. So what will be the percentage now at this stage? 150 minus 60 divided by 60 into 100. You do that. So that will give you the increase in the output. Where is calci? see here. So 150 minus 60 divided by 60 into 100. So that will give you how much percentage? 150 percentage. So that you are going to show here in this table, 150 percentage. Now you compare this, both this percentage increase in output and the percentage increase in the inputs. Output and input, when you compare here, only input is increasing 100 percentage, but the output that you are obtaining is 150 percentage, right? So this is called as what? Increasing returns to scale. Increasing returns to scale. So this is what you need to write in the below table. So when the increase in inputs is more than increase in output, so that is called as what? Increasing returns to scale. So I gave you on the screen also in words. So in the same manner, you double the capital and labor. So from 2 to 4, 2 becomes doubling means 4, 100% I am changing. And 6 doubling it, 12 it will become. So this will give you 100%. Always you take 100% of the input change. And the output here we need to, first law we got. Next law we need is constant returns or decreasing returns. So accordingly you take the output. So here it is taken as 360. So 360 minus 150 divided by 150 will give you how much? Into 100. 140%. What is this? 360 minus 150 divided by 150. That is giving you 1.4. So I have to reduce this into 100 means 140% it is given, right? I thought it is. So here you take it as 300, Amma. Then it will be equal to 100%. 300 minus 150 divided by 150 into 100. Anyhow, we need equal to 100%. No? So you make it here 300, not 360. So that will give you 100% of output. Okay. This is a mistake here. So you change that. Double 150. That's all. So you will get constant returns because we need to show all the laws in one single schedule. We are showing like this. So this is called as what? Constant returns. When the input is equal to output increase, then automatically that is called as what? Constant returns. So one more law we require is decreasing returns. So decreasing returns also we are increasing the input 100%, and instead of doubling this 300, you take 540 means this may also be giving you wrong value because I have taken this as 360, no? 540 minus 300 I have changed, no, there. So here also you change 300. So this may be giving you more. Okay, it is giving 80%. Okay, into 100. So which is less than the input. But I have shown here something different. 50% I have shown. Change this as 80. Okay, because I have taken here wrongly as 360 now. So if you take 360, you will get 50%. But don't take here 360. You change it to 300. So here percentage of output is less than the percentage change in the input. No? So that will give you the decreasing returns. decreasing returns to scale. So this is how you are going to show in numerical values, and you are going to create this law of returns to scale schedule. Inputs and the outputs. So increasing returns to scale, for increasing returns to scale, you draw it as a straight line flowing from left to right upwards. So name it as increasing returns to scale. And whichever is a straight line to parallel to x-axis, here parallel to x-axis we got now. So that is called as what? Constant returns to scale. So which is flowing from left to right downwards. So this is called as what? Decreasing returns to scale. So if you take a more number of values and if you plot out in this manner, you will get the returns to scale curves. So, but need not take three different schedules. You please remember this. So whenever increasing returns are there, the curve will be flowing from left to right upwards. And whenever it is constant returns, that constant return curve will be parallel to x-axis, and decreasing returns to curve will be flowing from left to right downwards. Okay, so this is what it is called as what? A law of returns to scale in the graphical manner. So why this increasing returns to scale appears, and what is that you have to explain here as I have explained in words. The same thing you explain in terms of words, how this is reflected. So that you have to write here. As I am showing on the screen, you try to write that. This is a very simple topic which you can easily write. So for this loss, assumption is that first assumption is that all the inputs will be changing, and this law is applicable to long run only. So like that, you write the assumptions of these laws. And there won't be any fixed inputs, because as we have taken in that previous laws, some factors are kept constant, no? Like that, no constant of any factor will be there, and all the factors of production can be divisible. Inputs are nothing but the factors, don't get confused. And how diminishing returns to scale is appearing, that also you can write in simple one statement I have shown on that below the schedule. No, the same thing you are going to write in terms of words. After completing explanation to the schedule and the graph, you give side headings of each law and you explain like this. Constant returns means percentage, a proportionate change in input is equal to proportionate change in the output. So when inputs are doubled, output also doubled. So it is a case of constant returns to scale. So this is how you are going to explain. That's all. In your own words also you can do that, but be careful while taking that, showing that increase in the inputs and the increase in the outputs. So that care if you take, that will be enough. It's very simple. So all the production functions we have completed. Now what is the importance of this finding of this production functions or loss of production analysis? Means this will be helping you to estimate what is the level of production that the company can do. Level of production means quantity of output that it needs to produce. So which we can say that level of production. How many number of products it has to produce. So when different combination of inputs are used, what is the output that you are obtaining? To know that, this analysis will help you. And it is also going to indicate you how one input can be substituted for other input. This is done in the case of the isocost and isocovariance case. We have substituted one input for the other input, no? So which is called as technical substitution. Marginal rate of technical substitution. To what extent you can substitute each input with the other input. So that to know that also this production analysis will is important, and you can consider this price also. So when you consider the price taken into consideration, and how the output is increasing, and where to which combination you need to uh, select. So that will be a question, no? So for that question, you are going to get answer by using this production analysis of least cost combination. So there in the least cost combination, we have obtained C combination as the least cost combination. No? So that a selection of the combination of inputs can be done. Otherwise, you cannot do that. So for getting the same 4000 output, because all the combinations are giving same output, so it will be very difficult to identify which combination you needed to select. No? So for that difficulty, you will be getting an answer. And this law of variable proportions and the law of returns to scale both can be called as input-output relationships. So law of variable proportions explains how the output is in short run. So as I said that in short run how the output is increasing with the input. And when laws of returns are, it is going to explain you in long run how all the inputs are changing and how the output is changing accordingly with the inputs. So all these can be known if there is no production analysis or production functions. We cannot identify what is the maximum quantity of output that can be produced, or how to manage in short run and how to manage in long run. So unknowingly, if you go on producing, so that will increase your expenditure, cost of production. So which will be increasing your price of the product, which may not be sometimes possible to increase the price. So if you manage this cost of production by managing all these types, applying these laws, you can easily reduce the expenditure on the inputs, and wastages can be reduced. And by that, if the expenditure is less, automatically the profits that you are going to earn will be more without changing the price of the product. So that is possible. For all these cases, you can use this production function or functions or production analysis. And one more small topic which is left over for short answer question. So that is Cobb-Douglas production function. Cobb and Douglas are the two people. So those who have experimented on this input-output relationship, and they have created one equation based on certain assumptions. So they have substituted capital and the labor, and how the output is changing. They have identified that. So they have given certain assumptions that, and they have also found that the constant returns to scale is going to be applied. And the assumptions of this Cobb-Douglas production function is, so you are going to get the constant returns to scale. and the inputs are homogeneous. So whatever the input that you are going to bring change should be same. Homogeneous means the same. So as capital and labor they have taken, only capital and labor are going to be bought changed, not the other. In between you cannot change the other inputs. And there is perfect competition. Perfect competition means here everyone, those who are interested to sell the product in the market can enter the market and sell the product, and if they are feel that they are not in profits, they can leave the exit the market also. So certain features are there to say that it is perfect competition. More the number of buyers will be there, more number of sellers will be there. So all these are the features of perfect competition. So if perfect competition is there, then only the equation that these people have identified can be giving you the result as they are going as they have expected. So if this market structure is going to change, automatically their law cannot be applicable. Production function cannot be applicable. And they feel that there should not be any change in the technology also, because they are going to bring change in the capital and labor. The other factor is technology. No, they kept that technology to be constant. So like this, they have given certain assumptions, and based on these assumptions, they have identified one equation, and they found that the how the output is functioning. That is, you are going to get the output. So, what is that equation? Let us see. So, this is the equation. See here, f of L comma k, or you can say that it is y. Okay. So, y is equal to a L power alpha k power beta. Okay. So, L stands for here labor, and k stands for capital, and y stands for the output. Y stands for the output. What is A? A stands for? A is a constant value that they have fixed. So that means if A, for example, 0.1 percentage, it is changing, 0.1 is taken. So what will be the change in the labor and capital they have identified? And what is alpha means? Elasticity of labor. Elasticity means to what extent the labor is changing. Change is nothing but the elasticity. So that will be indicated here in terms of alpha value. And beta indicates the change in the capital. Both the change in the alpha value and the beta value will be equal to 1 whenever you are going to take the change in both the labor and capital. Okay, so this will give you the constant returns to scale. How to get this constant returns to scale? By using this, they have identified this equation and will give you the constant returns to scale. This is what it is on Cobb-Douglas production function. So why this production should be increased or decreased? What are the advantages? What are the disadvantages due to increase in your input and in output of any product, any manufacturing unit? So that we have to see in the next topic, that is called as what? Economies and diseconomies of large scale production. Large scale means large quantity of output you if you are going to produce. So you will be having certain advantages. Economies means advantages. Diseconomies means disadvantages. What are they? That we will see. But I will give you the list first. We will discuss in detail in the next class. So let us see what are the economies of large scale production. So this can be divided into two types. One, internal economies will be there, and external economies will be there. Internal economies means within the company some advantages will be there, and external means outside companies also, some from the society. You will be getting certain advantages if you are going to produce in large quantity. So internal economies, we can divide them into different types again. One, it is technical economies, managerial economies. Managerial means management related economies. Marketing economies, marketing advantages will be there. And financial economies and risk bearing economies. And you are going to conduct certain research due to which you will be having certain advantages. And outside the company, economies of concentration, economies of information, economies of welfare. So like this, you can divide them, and we will go in detail about all these economies. And in this economies also, these all these same type of disadvantages will be there: technical, managerial, marketing, financial, etc., etc. So, but the thing is here, technical diseconomies, managerial diseconomies, like this, disadvantages will be there. So that we will see in the next class in detail. So any doubt in understanding this law of returns to square? Cobb production function will be given for you in short answer questions only. You cannot expect that in long answer question. With that, we are going to end here today. If you are having any doubts, you can ask. Till now, we have discussed so many of topics.